Today we are going to revisit some of our old friends in Lesson 83. We're going to talk about the product rule for exponents, and we're going to talk about the power rule. And I'm going to remind you of exactly what those are in just a second. But we're going to put one little twist on it with both of these. We're going to talk about them using variables, which means, brace yourself, exponents with letters. Letters for exponents. I know, it's weird, but don't let it throw you because it's not really any harder than using numbers. Let me remind you of what the product rule for exponents looks like. It tells us that if we have a base raised to a power, let's say the base is x and we're raising it to the power of m, and we want to multiply that by the same base being raised to a different power, all we have to do is write the base and then add together the two powers. So the product rule tells us add the exponents. The power rule is the other one we're going to use today, and that's in the case where we've got a base with an exponent and we're raising it to a higher exponent. So we're raising our base to a power, and in that one we take the base and remember we multiply the exponents. These are review. We've used them lots of times in the past, but I'm putting them fresh into your brain because we're going to apply them now. Look at example 83.1. I copied it out ahead of time because my eyeballs really have to strain to see those little exponents still. It's going to take me about 8 weeks before my eyes are, before my close vision is really strong again. So I have to struggle with that. It's on page 343 in my book. And what we're going to do, in this case, you can see we've got matching bases. We've got a pair of x's and a pair of y's. They each have exponents with creepy letters in them. You can see they're really complicated, but we're not going to let that throw us. We're simply going to use the product rule for exponents, and we're going to add the bases. So first, let's just pull the two x guys together. There's x to the a and x to the a over 2. So with those two, we can simply look at the bases, or the exponents themselves. We've got a plus a over 2. We simply have to add those. So it kind of flips your brain out, but simply think, what do we have to do in order to add fractions? Well, they have to have matching denominators, like always. So we're going to have to get this dude set up with a 2 on the bottom. If we want a 2 on the bottom, then we need a 2 on the top. So we'll multiply 2 over 2. And that will lead us to having, we'll multiply that, 2a plus a over 2. Does that make sense? We just added those two together. And then we can simplify this one step further. I'll go like this. That equals 3a over 2. So our x's we can represent with a single base, and our new exponent will be 3a over 2. Does that make sense? That's how we summarized the exponents on the x bases. So now we're going to do the y's. Let's do them. Gosh, I gave myself not enough room. We'll do them up here. The y terms are, we've got a 2x, which is right here, and then we've got a 3x over 4. And we need to add those two together in order to come up with the new exponent for our combined y terms. And in order to add these, we have to have matching denominators. So we'll multiply this one by 4 over 4, and this will become then 8x plus 3x over 4. See, I just multiplied the 4 times the 2 to get 8x. I add them, and so then this will simplify to 11x over 4. So I'm going to put my y, and I'm going to put 11x over 4. That, you guys, is our final answer. All right? Weird, ugly, kind of scary looking, but really not very hard if you think about it. All right, let's try one more. In this case, we've got a similar looking kind of thing, but instead of them all being in a row, multiplied, we've got 2 on top and 2 on the bottom. So our first step in this one, we've got one more new wrinkle, as John Saxon would. And so what we're going to do first in this one is we're going to move all terms to the numerator by using negative exponents. And I'll remind you of how that looks. Okay? We start with x to the a minus 2. Now we've got another x here, and we want to bring him up top. So we'll make him x to the minus a over 2. Does that make sense? We just put a minus sign in front of him in order to bring him up to the numerator. And then we'll do the same thing with the y. We have y to the a plus 4. And then we've got a 2a in the denominator, so our fourth term will be y to the minus 2a. Does that make sense? We just use the negative exponents to pop the exponents from the bottom up to the top. No tricks. And now we've got a problem that looks just like our previous problem. And what I'm going to do is I'm going to pause here, or ask you guys to pause me actually, and let you finish this problem on your own. And actually what I'd like you to do is pretend I didn't show you that and work the problem from start as if you work through this yourself and make sure you get the same answer as me. Remember, please use the solutions manual to follow this step by step, so that you can be sure you're getting it right all the way along. All right, I will let you go ahead and do that. I'll cross this off, and go ahead and unpause me when you're ready. Okay, back to part B. Part A was using the product rule. Part B, we're going to use the power rule. We just reviewed the power rule. It's when we're raising one exponent with one base with an exponent to a higher power. And here are a couple problems that I, again, copied ahead of time so I didn't get my mind blown. And all we have to do is we have to take this outside number and multiply it against the inside number. So let's just take this exponent off and look at it. We're going to have 2 times a plus 2, right? Easy. We'll distribute it, and we'll get 2a plus 4. So the answer to this one is x to the 2a plus 4 power. That is all there is to it, you guys. Scary looking, but I don't think that is too hard. So there's our answer to that one. I'm going to let you guys do 83.4 by yourselves, but again, this time we've got a denominator. So we're going to bring that up, but first, let me write this down. First, use the power rule to simplify, and I'm going to call them double exponents. They're not really double exponents. That's not a technical term. But when we've got one on the inside and one on the outside, I'm referring to that as a double exponent. We're going to simplify these first. Then, let's do that first, and then we'll take the next step. So, if we have to multiply the b times the a, then we have x to the ab. And if we have to multiply, let's see, that's a b plus 2. Let me double check that. Yes, it's a b plus 2 on the outside. Then we have to multiply that. Then we have y to the ab plus 2a on the outside. And then on the bottom, we don't have a double exponent there. We just have x to the minus a. Okay? So we've done this. We first used the power rule to simplify the double exponents. And now our next step is bring terms in denominator up to numerator using negative exponents. And we did that last time in the last problem, so I'm going to let you guys take the problem over from here. We've multiplied to simplify those. Now we're ready to bring this up. Remember, we're multiplying. We're going to be multiplying these together and then see if you can take that problem the rest of the way. All right? Work together. Look in the book if you need a little help. Whoops. Here, let me make sure you can see my notes. Sorry. You might not have seen those. Go ahead and give this one a shot. This one really builds on everything we've done in the whole lesson. So if you can do example 83.4, which again is on page 343, then you are golden for lesson 83. Good luck.